Today, we are diving into one of the most mind-blowing and terrifying concepts in all of space science and futurism. The Nicoll-Dyson beam, a theoretical megastructure that lets an advanced civilization take the full unbridled power of an entire star and turn it into a directed energy weapon capable of reaching across hundreds of light years. This is not just wild science fiction, it is a rigorous thought experiment rooted in the work of legendary physicists, cosmic engineering, and our understanding of how energy shapes the fate of every civilization in the universe. To truly grasp the Nicoll-Dyson beam, we must start at the very beginning, with the idea that made it all possible, the Dyson sphere, first proposed by physicist Freeman Dyson in 1960. Dyson did not wake up one day and imagine a solid metal shell surrounding the sun. He was solving a simple, unavoidable problem for any growing technological species: energy scarcity. As a civilization advances, its need for power grows exponentially. Fossil fuels, nuclear fission, wind and solar panels on a planetary surface can only go so far. Eventually, a species will outgrow its home planet as energy supply and look to the only source powerful enough to sustain its expansion, its parent star. Our sun alone releases 3.8 multiplied by 10 squared watts of energy every single second, enough to power every human-made device on Earth for billions of years in just a few moments. Yet less than 1/billionth of that energy ever reaches our planet. The rest blasts out into empty space wasted. Dyson's solution was a Dyson swarm, a vast cloud of millions, or even trillions, of small satellites, solar collectors and habitats orbiting the star in tight overlapping paths. These structures would capture nearly all of the star's outgoing radiation, turning light and heat into usable, storable energy. This was not a weapon, it was a lifeline, a way for a civilization to ascend to Type 2 on the Kardashev scale, a ranking system created by Soviet astronomer Nikolai-Kardashev that measures civilizations by their total energy control. Type I controls all energy of its home planet. Type 2 controls all energy of its star. Type 3 controls all energy of its entire galaxy. For decades, the Dyson swarm was seen as a purely peaceful megastructure, a symbol of progress and survival. Then came James Nicoll, a science fiction writer and futurist, who asked a chilling logical question: if you can collect all of a star's energy, what stops you from pointing it at something? In the information age, Nicoll proposed a deadly evolution of the Dyson swarm: reconfigure the outermost layer of satellites into a massive phased array emitter, sinking every panel and mirror to focus all that collected stellar energy into a single, coherent, collimated beam. This was the birth of the Nicoll-Dyson beam, a weapon that does not just use energy, it weaponizes the very lifeblood of a star. Let us break down how this works step by step, in terms anyone can understand, no PhD required. A phased array is a technology we already use here on Earth, in radar systems, 5th-generation towers, and even some radio telescopes. Instead of moving a big dish, you control the timing of signals from thousands of small antennas to steer a beam electronically. The Nicoll-Dyson beam scales this idea to cosmic proportions. Each satellite in the Dyson swarm acts as one tiny element in the array. When activated in weapon mode, every satellite stops storing energy for cities like support or industry, and instead bounces, amplifies, and directs every photon it captures toward a single target. The effective aperture of this array is the entire width of the Dyson swarm, often hundreds of millions of kilometers across, making the beam incredibly tight and resistant to spreading out over cosmic distances. Unlike a laser pointer that diffuses into a faint dot after a few kilometers, a Nicoll-Dyson beam can stay sharp and deadly for tens, even hundreds of light years. The power of this beam is almost impossible to comprehend. At full strength, it can strike a planet hundreds of light years away and strip away its atmosphere in hours, boil its oceans in days, or vaporize the entire rocky body in weeks. This is not a weapon of war as we know it. It is a weapon of erasure. It could end all life on a target world without a single ship, a single soldier, or a single bomb. But here is the critical twist. The Nicoll-Dyson beam is not only a weapon of destruction. Like many advanced technologies, it has dual uses that could lift a civilization to new heights of exploration and survival. One of its most important peaceful applications is propelling laser sail spacecraft to near light speeds. A laser sail is a thin, lightweight membrane that rides on the momentum of photons. A small laser on Earth can push a tiny probe a little faster. A Nicoll-Dyson beam can push a massive interstellar arc, or a fleet of probes, to a significant fraction of the speed of light, cutting travel time to nearby stars from millennia to decades. It can also be used as a cosmic beacon, sending focused high-energy signals across the galaxy to announce a civilization's presence or transmit data across impossible distances. Some theoretical models even suggest it could be used to gently nudge dangerous asteroids or comets away from an inhabited planet, acting as a planetary defense system, far more powerful than any missile or laser we can build today. It can also transfer energy to distant outposts, keeping colonies alive where solar power is too weak or unreliable. This duality, creator and destroyer tool and weapon, is what makes the Nicoll-Dyson beam so endlessly fascinating. It forces us to confront a universal truth: any technology powerful enough to save a civilization is also powerful enough to end it. Now, let us talk about the science and engineering that makes this concept plausible, even if it is far beyond our current capabilities. First, we must dismiss the myth of the solid Dyson sphere. Many people picture a rigid, hollow ball surrounding a star, but that is physically impossible. The gravitational stresses would tear the structure apart instantly, and no material we know of could withstand that kind of force. The Dyson swarm, by contrast, is dynamically stable. Each satellite orbits the star independently, like bees, around a hive, adjusting its path as needed. This makes it the only feasible foundation for a Nicoll-Dyson beam. Building such a swarm would require dismantling a planet, most likely a gas giant like Jupiter, for raw materials. A gas giant has enough mass to build trillions of satellites, each lightweight and efficient, using advanced materials like carbon nanotubes or graphene that can withstand the star's heat and radiation. Once built, the swarm would operate with artificial intelligence, coordinating every satellite to maintain perfect alignment when firing the beam. Even a tiny error in timing or position would scatter the beam and render it useless, so precision is everything. The energy storage is another key piece. The beam cannot fire continuously at full strength. It would drain the swarm instantly. Instead, the satellites store energy over hours, days, or weeks, building up a massive charge before releasing it in a single devastating burst. This makes the Nicoll-Dyson beam a weapon of patience, not speed. A civilization could target a distant star system, charge the beam for years, and then unleash it, knowing the beam will take centuries to reach its target. This leads to one of the most haunting ethical questions surrounding the Nicoll-Dyson beam: cosmic accountability. If you fire a beam that takes 100 light-years to hit its target, the civilization you aimed at may have collapsed, made peace, or evolved into something entirely new by the time the beam arrives. The beam cannot be recalled, cannot be redirected, cannot be stopped. It is a bullet fired into the future, a decision made by one generation that dooms a world many generations later. This changes the very nature of warfare. It is no longer about winning a battle. It is about committing a cosmic crime that echoes across time and space. For us here on Earth, the Nicoll-Dyson beam is more than a thought experiment. It is a tool for searching for extraterrestrial intelligence. NASA and other space agencies have been scanning the skies for decades, looking for signs of Dyson swarms, specifically unusual infrared radiation signatures that cannot be explained by natural stars or nebulae. A Nicoll-Dyson beam would leave an even more distinct signature: a narrow, hyper-energetic beam of light, cutting through space, unlike any natural phenomenon. If we ever detected such a beam, it would be proof that we are not alone, and that another civilization has reached the terrifying heights of stellar power. It would force us to ask, are they peaceful, using their beam to explore and survive? Or are they hostile, pointing their star-powered weapon at worlds we cannot even see? This uncertainty is at the heart of the Fermi paradox, the question of why we have not found intelligent alien life, despite the vastness of the universe. Some scientists have proposed that the Nicoll-Dyson beam is part of the answer. Any civilization bold enough to build such a weapon may either destroy itself or be destroyed by others who fear its power. It could be a cosmic filter, a barrier that few civilizations survive past. The idea of a star weapon also changes our perspective on our own place in the universe. Right now, humanity is a Type 0.7 civilization, barely clinging to Type I. We fight over small patches of land, limited fossil fuels, and trivial differences, while the full power of the sun burns unused above us. The Nicoll-Dyson beam shows us both the pinnacle of what a civilization can become, and the danger that comes with that power. It teaches us that progress without wisdom is not progress at all. It is just a faster path to destruction. As we look to the future, as we build better telescopes, develop better energy technologies, and reach farther into space, the Nicoll-Dyson beam remains a touchstone. It reminds us that the universe is not just a place of beauty and wonder. It is a place of immense power where the line between creation and annihilation is thinner than a photon's path. Please like, comment, share, and subscribe to the channel.